we have another condition for any quadrilateral to be a parallelogram. So that condition we are going to understand in the form of theorem. This is theorem 8.8, which says a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Look at this figure. ABCD is a quadrilateral. Given information is a quadrilateral. This is the symbol for quadrilateral, a quadrilateral ABCD, in which now we are given conditions. Those conditions are a pair means one pair of opposite sides. That pair is AB and CD, in which AB is equal to CD and AB is also parallel to CD. Alright, so ABCD are parallel as well as equal. We are asked to prove that it is not just a quadrilateral, it is a parallelogram. We have to prove that ABCD is a parallelogram. No construction, nothing is required, it's very simple. Observe two triangles. Because AC is a diagonal, this diagonal has divided this quadrilateral into two triangles, which are ABC and CDA. So in proof we would say in triangle ABC and triangle CDA, first matching part, AB is equal to CD. This information is given. Second is, look at these angles. ABCD, two parallels intersected by a transversal. So alternate interior angles are formed. So these alternate interior angles are equal. So angle 1, I am marking this as angle 1 and this is angle 2. Angle 1 of triangle ABC and angle 2 in triangle CDA are equal. Which angles? These are alternate interior angles. Another third matching part, AC is a common side. It's shared by triangle ABC. It is contained in triangle CDA as well. We would not say AC is equal to AC. You know why? Because angle 1 and angle 2, since they are equal, it means A and C would overlap with each other. When you try to cut this triangle, paste on the other, A and C would cover each other. Hence, AC is equal to CA. This is a common side. Which rule do you see? This is, we took a side, then we took one angle, then another side. So SAS rule. Triangle ABC is congruent to triangle CDA by SAS rule. And if these triangles are congruent, what can you say about other pair? BC and AD must be equal. BC is equal to AD. This is by CPCT. So AB is already equal to CD. BC is proved equal to AD, and if both the pairs of opposite sides are equal, the figure would be a parallelogram. Therefore, ABCD is a parallelogram. Hence, this is how you would prove this result. It is one of the important results. It would be used in many questions because you would be given a condition that there is just a quadrilateral, a pair of opposite sides is parallel and equal. So then we would use the result that it is not just a simple quadrilateral, it is a parallelogram. Now we are taking up one question from exercise 8.1. Question says, if the diagonals of a parallelogram are equal, show that it is a rectangle. So as you see this figure, ABCD is given as a parallelogram. This is a parallelogram. Opposite sides are parallel and equal. Okay. Another thing, AC and BD, these diagonals are equal. This is added on information given. We need to prove that this figure is a rectangle. So a parallelogram can be called a rectangle if we are able to prove that at least one angle is 90. Okay, either A, B, any of the angles if can be proved equal to 90 degree, then this parallelogram would become a rectangle. So let's see which triangles would help us to prove this result. So in proof, I would be taking triangle ABC, okay, ABC and BAD. In these two triangles, ABC and triangle BAD, first thing is ABC has got side BC, BAD has got side AD. So BC is equal to AD, opposite sides of parallelogram. We know opposite sides of parallelogram are always equal. That's given also. Another is AC and BD. This is given. This is extra information given to us. So AC is equal to BD. This is given. And then look at this common base AB. AB is equal to BA. That's a common side shared by both the triangles. So AB, BA equal, common. Rule is we have used all three sides. So side and then this side and third side. So triangle ABC is congruent to triangle BAD by triple S rule. And if triangles are congruent, that means angle B must be equal to angle A, because in ABC we have angle B. In triangle BAD we have angle A. This implies angle ABC is equal to angle BAD. This is by CPCT. But since these are two parallels, this is a transversal, these are co-interior angles, angles formed on the same side of transversal. They are co-interiors. And what do you know about co-interior angles? They add up to 180. It means angle A and angle B would add up to 180. Or we can say these two angles would add up to 180 since they are co-interior angles. Now if they are adding up to 180 and they are also equal, using these two results, if I say ABC, BAD are equal, can I say ABC added to ABC? I've replaced BAD by ABC and this is equal to 180. This indicates twice of ABC is 180 and twice of ABC if is 180, what would be measurement of ABC? This becomes 180 upon 2 and hence it's 90. And that's a general rule. In any parallelogram, if you are able to prove that one angle is 90, it becomes a rectangle. There's no need to mention any other detail because we know if this is 90, these two are equal, this would also become 90 and opposite sides of parallelogram are equal. So if B is 90, D would automatically become 90 and so would be the case with angle C. I'm sure this is clear to everybody. Let's now take question 4 from same exercise, which says ABCD is a square with AC and BD as its diagonals and we need to prove that these diagonals are equal. So first part is ACBD, we should be able to prove that they are equal. Second is diagonals bisect each other at right angle. Bisect means these parts, the point of intersection of diagonals O has divided AC into equal parts. AO is equal to CO and BO is equal to DO. And after that you should be able to prove, third part demands that angles over here, angle AOB, BOC, COD and DOA is each 90. So we have three parts to prove. Let's begin with the first one. For first case, we need AC, we need this complete side. So AC and BD would be obtained if we take triangle ABC and triangle BAD. So let's begin writing in triangle ABC and triangle BAD. First one, AB is equal to BA. That's a common. You can make out from here. AB is equal to BA. Common base. Then angle in ABC, angle B. And in BAD, angle A. This is each 90. And BC is equal to AD. Side BC is equal to side AD. They are sides of square. We know opposite sides of square are equal. So the rule is side, then came this angle, another side. Therefore, by SAS rule, triangle ABC is congruent to triangle BAD. So once you have proved part number 1 by CPCT, you can say, once you have proved that these triangles are congruent, by CPCT we can say AC is equal to BD. So your first part is done. For second part, we need to prove AO and CO are equal, BO and DO are equal. Now these are contained in these smaller triangles. Triangle, if I take triangle AOB and take triangle COD, let's see how do we prove it. In triangle AOB and triangle COD, one is AB is equal to CD. We know they are sides of square. Undoubtedly, sides of square must be equal. And then look at these angles, angle 1 and angle 2. Angle 1 and angle 2, why are they equal? These are alternate interior angles. In AOB it's angle 1, in COD it's angle 2. Alternate interior angles. Another, look for the other end, angle 3 will be equal to angle over here, which is angle 4. So 3 and 4 if are equal, reason is same, they are also alternate interior angles. Therefore triangle AOB is congruent to triangle COD. They are proof congruent by which rule? Angle, then came this side, then came this angle by ASA. By ASA rule, triangles are congruent. And if triangles are congruent, what can you say about these concluding sides, the remaining sides? AO must be equal to CO. AO is equal to CO. This is by CPCT. Similarly, the other one, BO is equal to DO. Same reason. So our second part is also proved that diagonals were equal and they bisect each other. For the third part, we would be taking consecutive triangles because we are asked to prove that these angles are 90 each. So I am taking triangle AOB and COB. In these two triangles AOB and COB, first is AB is equal to CB. AB, CB, why are they equal? They are sides of a square. Then next is AO is equal to CO, we proved in the previous case. AO is equal to CO, proved above. Just write proved above, that would go. And one thing more, that's a common side, BO is equal to BO. Now why do we simply say BO, BO? Because over here O would remain at its place, C would cover A, so B would remain as such, so OB is equal to OB or BO is equal to BO. You don't have to flip it completely. So this side is common side, and according to the matching parts, the rule is SSS by triple S triangle AOB is congruent to triangle COB. So triangles are congruent by triple S rule. This means angle AOB would also be equal to angle COB. Okay, by CPCT these angles are equal. Now since AC is a straight line, that means these two angles are actually adding up to 180. It's a linear pair, it's a case of linear pair. And if they are adding up to 180 and they are equal even, can I say it's twice of AOB equals to 180? And hence if twice of AOB is 180, AOB would be 90. And if AOB is 90, opposite angles each 90, and if this, because they are equal, this is 90, here also vertically opposite angles would make it 90. So this proves our third part,